Okay, so you're happy this one's slightly trickier because it's got surds in. So what could we do?
Expand it first.
Exactly, expand it first. You see the brackets, you're like, okay, I know how to deal with brackets, I could expand them out. So let's expand them. What do we get if we expand this out?
AB.
Good.
Minus 4A.
Yeah.
Root
5.
root 5.
Yeah, good.
B root 5 plus B root 5.
Good.
Minus 20 equals.
Yeah, exactly, equals that lot. Okay, equals that lot. So I'm just going to keep that on the left-hand side for the time being. Okay. Good, are you happy why that's got to be 20, everyone? Because it's root 5 times by 4 root 5. Of course, it's negative times a positive, so it's got to be negative as well. So root 5 times root 5 makes 5. 4 times 5 makes you 20. Okay. Good, all right. Now what?
AB minus 20 will equal 8. And then you factorize the third thing.
Yep.
And then it will equal the.
Absolutely right. Do you see that? So the aim is you've got this on the left hand side. Are you happy you can't really do much more with the simplification there? Because you don't know what AB is, you don't know what the A is, and you don't know what the B is. Okay? But you're trying to say that thing is exactly the same as that thing. So why not make it look the same? So in other words, all of the numbers come first. I say numbers. All of the numbers without a square root in come first, and then the numbers with the root 5 in come second. So let's group them together. Do you see that? So AB, are you happy that's just going to be a number? Okay. Negative 20, that's also a number. So I'm going to group those together. It hasn't got a surd in, so I'm going to group them together. So in fact, let me box these. So I've got AB, and I've got negative 20. I'm going to put those first. So I've got AB, take away 20. Okay. Then you also notice that I've got stuff involving square roots. I've got a take away 4a root 5, and I've got a plus b root 5. So I'm going to group those together as well. I'm going to write the b root 5 first, and then minus 4a root 5. Okay, minus 4a root 5. And then you notice that there's a root 5 in both of those terms. I'm going to factorise that out because there's only one root 5 on the right hand side. So I'm going to go plus b minus 4a root 5, and that's obviously ab minus 20. Okay, that's kind of a roundabout way of doing this, but effectively that now looks exactly the same as that. Doesn't look much like it, but I promise you it is. Because if you have a look, do you notice that there's a number here? There's ab minus 20. Okay, on the right hand side there is just a number without any root 5s in. So they have to be the same. Yeah? So AB minus 20 has to be the same as 8. Has to be the same as 8. Then you can solve that, obviously. Yeah. Okay. You notice as well that there's numbers with just root 5s in. So this term here must be the same as this term here. Do you see that? So would you be happy if I just deal with the root 5s later, so the root 5s don't affect things? That thing has to be the same as the coefficient of the root 5, the number in front of the root 5. So I'm saying that b minus 4a must be negative 9. Do you see that? So I've basically taken something here. You happy with how you get here? The idea is that I just group everything together to make it look like the right-hand side. Okay? Now a mistake would be to start taking a's and b's and crossing over the equals. Like keep all the a's and the b's on the same side, keep all the a's and the b's on the same side, and just have the things which you know on the right-hand side. Because as soon as you start crossing over a's and b's, are you happy there's one equation here, one equation and two unknowns? Now ordinarily that would mean that you couldn't solve it, but actually in this case you can. As long as you keep them separate, all the a's and b's on one side and the thing which you know on the other side, then the idea is that you just make the left-hand side look like the right-hand side. Okay. So let's finish this off now. Now I've got my two equations. If I solve this, would you be happy that AB would be equal to 28 just by adding 20 to both sides? And I could also say that B is equal to 4a minus 9. Yeah? And what I need to do is just stick that in there. So whenever I see a b, I just write 4a minus 9. So let's do that. I have a multiplied by b. Well, remember, b is 4a minus 9. That's got to be equal to 28. Okay, 28. Then I just expand that out, so I get 4a squared minus 9a minus 28. It's got to be equal to 0. Remember, it's a quadratic, so I've set everything equal to 0. Now just try and solve that. Does it factorise? Have you done it, Briley? Have you done this?
Yeah.
What did you get?
No, I haven't.
You haven't done it yet? Okay, that's fine. Let me stick it into GeoGebra for me.
4 and
Have you done it?
negative 7 over 4.
Okay, so a is equal to 4, or a is equal to negative 7 over 4. Good. So therefore, b is just going to be 4 lots of that take away 9. So b has got to be equal to 16 take away 9, that is 7. Or b is equal to, that's going to be negative 7 take away 9, that is negative 16. Okay. So once I'm here, I just stick it into this equation here, because I know that b is equal to 4 times a take away 9, and that gives me those two solutions there. Now that one was slightly trickier, definitely slightly trickier, because it got you to actually form your simultaneous equations first. So you actually had to form your simultaneous equations. But are you happy that just by following logic, just by following your mathematical intuition, you're going, oh, okay, 2 brackets, expand those out, why not? Don't know what else to do. And then you just basically make this thing look like this thing, compare the coefficients, so number, something root 5 in, something root 5 in, you know they have to be the same. So ab minus 20 equals 8, b minus 4a equals negative 9. Once you're here, I think you're okay.